So how's everybody doing today?
Good.
Awesome. For those who don't know who I am, my name is Griffin Sturkey. I am the quality manager over at Owen Steel, previous instructor here at Midlands Tech. I know just a little bit about the structural welding code. Very glad to be here. Excited to talk about this. So, as some of y'all know, we had some new codes come out this past year, updated from the 2020 edition to the 2025 edition. And this main PowerPoint in this talk is to go over some of the changes. Right? So, starting off, does anybody know what a code is? Does anybody else know what a code is?
I can imagine it, but I can't tell you the definition.
The guideline.
Guideline, specification.
Industry standard.
Standard. Is there a difference between a standard and a specification and a code? Yeah, right? Generally, specification is whenever someone specifies something. Usually it's done by an engineer or somebody that has some type of investment in a job to her. They want to make sure a job's done right. And really the whole reason why we have codes is to make sure that a quality standard is met, right? To make sure we don't have failure, right? And sometimes there's also guides, right? As an example, DOT, a lot of people that specify what bridges should be made, right? Department of Transportation entities. They actually issue design guides because they want you to fabricate it in a way that's economical for you and relevant to the structural integrity of what you're actually fabricating. But jumping around a little bit. So starting off, we were talking a little bit about what is a code. More specifically, are there a lot of codes? What are the codes used for? What is D1.1, right? Has anybody heard of AWS D1.1 before?
Yep.
You raised your hand, Lane. What's AWS D1.1?
That's our standard for structural welding code.
Yeah, it's a standard structural welding code. It's for welding structural steel, right? Generally, it's defined as steel that is greater than 1/8 of an inch that's used for structures, right? It's pretty straightforward. So if I have steel that's less than 1/8 of an inch, am I going to use D1.1 on it? Probably not. There's a different code for that, right? There's a sheet metal code. It's D1.3. I have a chart right here of some of the different applications and the codes that match it, right? So for structural fabrication, we have D1.1, D1.2, really all of the D1, AWS D1 codes is a structural, right? So, example, like if you're welding rebar, right? Rebar for embed connections, that's D1.4, right? D1 is a structural welding code for bar and reinforcement. Has anybody ever heard of ASME? Anybody in here want to be weld on vessels or pipe at some point? Maybe. A lot of people get qualified to ASME Section 9, ASME Section 9 for their qualifications, right? So pressure vessels, ASME Section 9 for procedure approval and welder approval, right? Got my structural fabrication. And whenever you see all these BS's, it is a little bit of BS. They're British standards. That's hilarious.
Do y'all see British standards?
No, I don't see any British standards for what I do. It is becoming a lot more relevant as AWS is expanding their horizons to be applicable overseas. So there's a lot of merging going on right now, making basic principles the same, right? But ultimately, AWS is the American Welding Society. AWS D1.1 is the most widely used welding code in the world, right? Even though it's the American Welding Society code, it is still recognized in multiple countries. It is the standard for the design, fabrication, and inspection of structural applications. Okay? So we all know what a code is, and we know what AWS D1.1 is, right?
Yes.
Thank you. I like it when people talk back to me. Yeah. Okay, so before we talk about the changes, before we talk about what's actually going on in the code, we need to know how it's organized. Do we have any CWIs in the room? Do we have anybody that wants to be a CWI one day? Hey, more hands. That's good. So I'm sure you've heard everybody say this before. It's not about memorizing a code. It's about being able to find the information, right? It's about being able to find the information, because if you try to memorize every single word and every single sentence, you'll be chasing something that's never going to happen, right? You can be very knowledgeable, but it really comes down to being able to efficiently navigate and know where things are and how to find them. It's not about knowing everything, it's about being able to find the answers. So most codes are organized in a linear fashion. When I say that, before we can work on anything, we need to have a scope. We need to know what we're talking about. What controls what we're talking about, right? How is it defined? So I have my general requirements, my references, what other codes play into this one, what dictates what I'm talking about. Terms and definitions is huge because we need to know how to interpret the language, right? All of that has to be established before we can actually start our fabrication process. That's why I have these separated out. Before I can do any of this, I need to know the context that I'm talking about. If you look at any code, the start of it is going to give you your scope and your general requirements, okay? Then it should be going into design, right? Before I can actually build anything, before I can start fabrication, someone has to design it. We got to know what we're doing, right? Or you can wing it. Sometimes winging it goes well, sometimes it doesn't. But if you're doing code work, it's always going to be designed, right? You do work in coordination to a plan, right? And then we know what we're actually building. It's designed. Before I can start welding, before I can qualify welders to do something, they have to work to a procedure, right? Yeah. I have to qualify my welding procedure. Now, AWS and a lot of, well, mainly AWS, has pre-qualified welding procedures that are proven, so it saves fabricators the time and energy and money in doing all these extra qualification tests, right? That's why they want you to look at what you can pre-qualify before you spend a lot of money to qualify, right? That's why they have it before. They want you to go through your options. Qualify my procedure. Once I have a procedure, once I've done testing for a procedure, then I can get my welders and qualify my welders to the procedure, right? So I need to know my parameters, I need to know my application, and then I make sure the people that are doing the work can do it within the parameters that I have now specified in my welding procedure specification, my WPS, right? Now I know what I'm building, I've qualified my procedure, I've qualified my welders. Now what do? We've done all this work, getting ready to do the work. What's the next step? Doing the work, right? Fabrication. We have clause 7 is fabrication. Once something is fully fabricated, we did it the right way. We now need to verify that it was done the right way. That is done through inspection. Done through inspection, right? And then I generally have auxiliary clauses that follow, right? Something that might not necessarily be in the linear line of progression, but can be important for different applications, right? Things such as stud welding, tubular structures, and strengthening and repair of existing structures, right? So now all of y'all are experts and y'all can take your CWI exam for the code book and pass it, right? Yeah, it's just that easy. There's a lot more to it, but that's a general breakdown of AWS D1.1. This is a list of all the changes. I'm not going to break this down on these tiny little words, but we are going to talk about the different clauses and what changed in them. Okay?
That's not so bad.
That's all it is. There was a lot more changes to the 2020 edition.
I was about to say this.
Yeah.
Pages were.
All right, but as you can see, there was something changed in most codes in the section except for strengthening and repair of existing structures. So starting off, they redacted one specification from the code, just for preference, or not preference, but reference, sorry. That list that I send you, I'm starting at the top of that list and I'm working down as far as explaining it. So we're going everything that was there. And by the way, this PowerPoint can be made available for anybody in this room that wants to have it as a reference. Okay? So one thing they removed is A536, right? So basically what A536, it's a filler metal specification, right? Which tells you, it groups your different electrodes together, right? What it did is it combined all of these different specifications to make one big gnarly specification that's a little bit more broad, and it lasted for about 10 years. They tried it in industry for 10 years, and people still use these anyway, and no one used A536 because it wasn't practical, right? So if something doesn't make sense, what do you do with it? Yeah, change it, get rid of it. I don't want it anymore, right? So it's no longer part of the code. It's no longer recognized. As other editions of other AWS codes come back out, it will also be removed from those codes. Okay? Didn't even make it 10 years. It was initiated in 2016. All right. Normative references, these are all the cross references to other specifications that were added. So we took one out, we added these, right? It goes over some surface preparation for cleanliness. SSPC is actually a painting specification, by the way. I'm talking about this one right here. That's for paint applications. Everything else generally refers back to the testing of welds, both non-destructively and destructively. So we have mechanical testing, which is generally destructive. That means once I'm done testing, can't use that weld anymore. And the other ones are for non-destructive testing, so testing that I will perform on welds that are going to stay in service, right? They're still going to be used. Before I actually talk about the definitions that were added to the code, I want y'all to know how definitions are grouped in the code. So they're broken into 3 categories. One is welding terms compiled by AWS Committee of Definitions and Symbols. There's a whole book on that. It's A3.0, right? Terms that are specifically made for the structural welding code, D1.1, but they only apply to UT. They generally follow with a little UT symbol behind it. And then other items which have an asterisk, which directly relate to the structural welding code, but might not be defined by A3.0, the book, right? If I'm going over a lot of information, it's okay to ask questions or ask me to slow down or something. Okay, so these are the new definitions that matter to us. There's a lot of other new ones, but I'm just a welder, so I don't care, right? These are the ones that I might actually care about. So I'm probably going to stand over here so y'all can actually see. So a contouring fillet weld. A fillet weld applied over a CJP and PJP groove weld and butt joints joining parts with unequal width or thickness. It says comer joints. It's supposed to be corner joints. for the purpose of reducing severity and abrupt changes of the surface. So basically, if you have a change of material thickness, we want to be able to make sure that we can define that weld that goes to bridge that, because we want stress to dissipate as it goes across a joint, right? I don't want there to be sharp edges to where it can build up stress and increase the potential for failure, right? So we want to be able to define that. We've talked about it in the code for years, but we need a definition, right? That's why that's in there. Faults indication, right? Notice how it doesn't have UT following it, so it applies to more than just ultrasonic testing. But I would say a faults indication is almost just as important, if not more important, than a not faults indication or a relevant indication, right? There's relevant, non-relevant, and then faults. But to be able to define a faults indication, it's important because there's going to be things to where we should question them, right? There's going to be things that look like it's rejectable, but it's not actually rejectable. We need to be able to define it. We need to be able to identify it, because ultimately it saves companies a ton of time, a ton of money if they're not fixing things that don't need to be fixed, right? Just as important as being able to figure out what's wrong is being able to figure out what's not wrong and accepting it, right? Awesome, cool. Flash. Has anybody heard the term flash before in a welding sense? It's generally related to stud welding. So whenever you use a stud gun, you have a stud, which basically looks like a rod. You place it on the metal. It arcs off. There's a little aluminized ball down there. Arcs off, and it does a weld all the way around the stud. That weld all the way around the stud is called the flash, right? Or flashing. Main goal is to get flashing 360 degrees around the stud, right? They want to be able to define that because they want to
say that maybe you should have slash flashing because it's more common.
Yes. So this is one thing, and we're going to talk about this a little bit more in here. These are directly copied and pasted from the code book. There's another thing to realize. The code book doesn't always list things the most easy way for us to understand. And the code book also has typos sometimes. By going through and talking about these things, it's extremely important to know where the code book, what the code book actually means, how it should be interpreted, right? I would say that flashing is probably a more relevant term there, because flash in a welding sense, I could be talking about arc flash, I could be talking about 100 different things. I mean, we've all seen welds before. It's bright. But yes, yeah. Hold back. A lot of the time, welders think that more weld is better. That is not the case at all. It's good to have welds that are the size that are specified, but a lot of the times holdbacks are specified, which is the length I hold back from the edge of a joint, right? To make sure that that stress can dissipate before I get to the edge of the joint. Because if not, and I weld all the way to the edge of something, all that stress also builds up in that edge, right? So I want to be able to let stress dissipate. So we want to be able to define that. We already reference it in the code, but we want to make sure there's a direct definition people can refer back to. We talked about faults indications. It goes back and it actually lists out what an indication is. MT or PT, that's mag particle or penetrant testing. And generally it didn't define indications for surface discontinuities for non-destructive testing. It only listed volumetric. So undermatching and matching and overmatching strength filler metal. I didn't have enough space on this to copy and paste the definition. Something we're going to talk about later, okay? Supplemental filler metal is, well, metal introduced into the weld other than the consumable electrode, right? That's generally for sub-art. Okay? So weld that's mainly there just to give you higher deposition and to make the weld look pretty. Right? And then this last one is ultrasonic testing. There's no words there. Why? Jim, what did I tell you about these definitions? They're copied and pasted, right? Mm-hmm. So I copied and pasted this one too. In the new AWS code, they have this term listed, but they don't have a basic definition for the term. They should have had a basic definition there. So sometimes, whenever they're producing codes, they don't give you everything. They're going to make mistakes sometimes. We need to interpret codes for what they are. We need to go by what the code says, but sometimes they're going to make mistakes too, like that.
But is it just trying to tell you that when it says UT in the book that it's meaning ultrasonic testing?
Could be.
When you're going through
That
the
makes
book
more
and it
sense.
says-
I could have been looking
Book
at it
that
wrong.
says UT and then it's just telling you that that's what
That's
they
what
mean.
UT
by it.
means.
Yeah.
By now you should have it. But they'll correct that on down the line if there's.
They will.
if there's
They
mistakes.
will. There's going to be an errata coming out very soon.
There'll be about 10,000 people calling them up telling me it.
Yeah, they're going to end up putting a short reference there. All right, awesome. Okay, layered. You were just talking about this probably 20 minutes ago as far as filler metal and matching and under matching. So this is in the design of welding connections. This is the most important change to the design of welding connections. So for our materials that are equal to or greater than 60 KSI, the specified minimum tensile strength of the filler metal shall meet or exceed the specified minimum tensile strength of the lowest strength base metal in the joint by not more than 10 KSI. So, if I have my base metal, the metal I'm welding on, right? And it is a 65 KSI base metal, right? 65,000 pound tensile strength base metal, right? Can I use an 80 series wire on it or an 80,000 pound electrode for a pre-qualified joint? Can I?
It just says minimum.
Shall not exceed.
Not.
That's for a pre-qualified, right?
This is, we'll get back to pre-qualified. Pre-qualified references back to this, but this is generally the design. So if you're doing work yourself, right, it might be good to know what filler metal you can use for certain materials and which ones you shouldn't, right? So I should not exceed the specified, or shall meet or exceed the specified minimum tensile strength of the lowest strength base metal in the joint. So I need to at least be as strong as my base metal, but I should not exceed the strength of my base metal by more than 10,000 pounds. What they don't want you to do, they don't want you to use filler metal that's super strong and brittle compared to the base metal around it, because then whenever your joint flexes,
Well done.
the weld doesn't.
Not at the same rate.
Not at the same rate, yeah. Your base metal is going to move, but your weld's going to want to stay stiff, and then you have a lot more likelihood for fracturing, right? And this bottom one right here, it's the same thing, but for materials less than 60,000 tensile strength, right? If it's less than 60,000, which is most materials people work on, the tensile strength for most materials and structural applications is 58,000 pounds. You shouldn't exceed by more than 20. The whole reason they put this part in there is because what's the number one stick welding electrode y'all learned to use 7018. What material do y'all weld on? A36 and 572. A lot of these, or all of them, have around 55 to 58. Well, I might be saying that wrong, Laird. A36 tensile strength might be under.
42 to 45 and A36.
Yeah, so really, I
Its
shouldn't.
ultimate yield is much lower. That's why
Yeah.
it's not used.
Yeah.
Your A572 grade 50, A992
Yeah.
keeled steel, somewhere in the 54 to 58 range.
Yeah.
But
So-
they're much better. in
Correct.
that ductility.
Yeah. So my A36 steels, I really shouldn't even be using a 7018 for most design applications. I should be using 6013s, and they make 6018s? I know they make 6014s, 6013s.
Jet rods work real well. 7014, 7024s.
Yeah.
Back in the old days, A36.
But my point is, if I'm using, a lot of the steel we mess around with today is A572. And it has a tensile strength of 58,000 pounds. And if you do 10,000 more than that, then that's 68, and your 7018 is still more than that. So they made that rule to where it can't be more than 20,000 instead of 10,000. That's why they put that provision in there. Now, undermatching. I've been seeing it a lot more lately to where engineers like to use undermatching filler material, so filler that's actually information at all, but it added some figures. The main thing for this is that if we are doing fillet welds on edge joints, and that edge joint is a 1/4 inch or thicker, as a welder, I should not be pulling my weld all the way to the top edge of that joint. I should be leaving at least a 16th land at the top of that. Should be leaving at least a 16th land at the top of that. Now, if the joint is, or the top connection, top piece of metal, is less than a 1/4 of an inch, 3/16 of an inch, generally it's hard to do much smaller than a 3/16 fillet weld, right? Good. So they allow you to meet that top edge of the material, right? But for most intensive purposes, you should have at least a 16th land across the top of your lap joints and corner joints. A lot of people, they just think they should throw the metal in there until it bulges over that top edge, and then whenever it goes over the top edge, they need to put more metal in there. That's not always the case. Yeah. Grinder for days. And this does not apply for T connections, right? Awesome. Pre-qualification of WPSs, this is referring everybody back to what we talked about before, right? As far as matching, undermatching, and overmatching. Just like they don't want you to design joints to where your filler metal's too differently than what you're welding on, they don't want you to design procedures that don't follow those rules as well, right? Now, this is a huge change for anybody that wants to do work for themselves or wants to be a CWI or wants to be able to write procedures one day. I used to have a table called it was just pre-qualified WPS requirements, but everybody calls it the table of maxes. It tells me the variables, the maximum variables I can use for writing a welding procedure. And it encompassed all of my welding processes. That's a pretty dang important table, right? I can't write a welding procedure without that table, right? As far as pre-qualified welding procedures go. What they did is they broken it up into the individual processes. Stick welding, MIG welding, flux core, and sub-arc, right? So it tells me my electrode diameter that I can use, the current that I can use, what my root bead thickness can be, filling cap bead thickness. So people wonder how welding procedures are written, pre-qualified welding procedures are written. They reference these tables, right? So I have stick welding, submerged arc welding, MIG welding, and flux core and metal core is generally grouped together because they're both tubular electrodes. Tubular as in hollow, not tubular as in cool, right? Do we have any questions about these tables or anything I've talked about so far?
So they took it from one table and broke it into each.
They took it from one table and broke it into 4, yes.
How much thicker the book get?
Well, it's only the changes that we talked about. So it's only like 20 pages.
That was from there, I remember it was that.
Instead of this, it's that.
Yeah, I remember it was that.
Yeah. For qualification, I'm talking about, mainly this is tying back to procedure qualification when I'm writing a WPS. They talk about how you should qualify your preheat temperature and what defines your interpass temperature and what you're going to write on a procedure, right? I would be extremely happy to talk to anybody who wants to talk about this more after the presentation, but I don't know if everybody wants to talk about the nitty-gritty for preheat and interpass temperature qualification right now. But I will refer back to this when we get to fabrication, okay? Awesome. We have that micro etch specimen? So we're going to be tossing this around. This is actually a test that we just did at Owen Steel. We're going to be looking at it on this side. I might turn this light on while, y'all still see that? I know, light's bright, sorry. I'm going to pass this around. This is a overhead qualification test, fillet weld soundness test that we did at Owen Steel for a job that we have coming through. That's a 4F weld, right? So an overhead fillet weld. This was to qualify a procedure so that we can do, well, overhead fillet welds, right? It's just a single pass fillet weld soundness test to verify that we can do it correctly. The requirement for this is that we do the test and we do 3 macro etches in order to prove the soundness of our single pass fillet welds, right? If I wanted to do more than a single pass fillet weld, then I would have to do a multi-pass fillet weld soundness test and an additional groove weld test to qualify our multi-pass welds, okay? Reason why I brought this, reason why we're tossing this around is because our acceptance criteria for macro etch testing has changed. Previously, they wanted sound fusion to the root, but not necessarily past for fillet weld soundness test. And that's probably still how it is laid out in a different part of the code, but this is just general acceptance criteria. So when you're looking at this, these are the things to judge to see if we actually passed our test or not, right? So you don't want any cracks. You want thorough fusion between adjacent layers of weld metal and between weld metal and base metal. Weld profiles conforming to a specific detail, but with none of the variations prohibited, so undersize or excessive convexity or concavity, and no undercut exceeding 1/32 of an inch. If you go outside of any of those bullet points, that test time passing around will fail. If any of y'all think that fails, then you can throw your hand up and then we can fight in the parking lot. Okay? Yeah.
Y'all doing a lot over here?
Not a crazy amount,
I was about to say.
but
We like
it comes
to be
up.
qualified just in case.
Just in case?
We deal with some very large stuff that keeps us from having to rotate
Turn it
things
over.
we don't want to more than we need to.
Yeah, I imagine so.
Yeah.
I've always been able to look it over.
For anybody wondering who this is Josh Amix. He's assistant plant manager at Owen Steel. This is Lane Simmons. He's a retired welding expert, master CWI. Retired. He's retired. He still likes when you bug him some. Awesome. We have any question about the test I'm throwing around or the requirements for the macro? Do y'all know what y'all are looking at? We're looking at that cross-sectional area of that weld. When I'm doing a macro test, I actually don't look at the face of my weld anymore. I'm just looking at that cross-sectional area and applying these requirements. Okay?
What was that done with?
Flux core.
Flux core?
It was a 1/16 flux core E71T.
How do you weld or measure the undercut?
So it really pops on a macro etch test because you'll see we actually scribed lines on there, fusion lines, and you'll see where it goes inside the scribe line. But most of the time we have a VWAC gauge or a bridge cam gauge where you can actually throw a gauge in there. There's a little prick that comes down and you can measure the depth of the undercut. Okay? When
Can any CWI read that, or do you have to be like a level 3 person?
there is an ASTM specification for macro etch testing, it's ASTM A340. Anybody can do it though.
Competent person, right?
Competent individual can perform it. AWS is very loose as far as what a CWI can do as far as auxiliary testing methods past non-destructive testing. For non-destructive testing, you need to be qualified to AS&T TC1A or CP 189. But for destructive testing, they let pretty much all CWIs can interpret it as long as they're competent individuals. I would say this, for any company that has a quality program, they need to reference AS&T, not AS&T, well, no, they don't need to reference that for macro. They need to reference that for all the NDT. The ASTM A340, they need to have in their quality manual. They need to reference that somewhere if they're going to actually be doing macro etch testing. Because in that spec, it actually gives you a procedure on how to perform it. So if anybody says, hey, what did you do this testing in accordance to? You should say, well, I got this reference right here to this procedure in the ASTM spec. And it basically, CYAs covers your butt, right? Awesome. Any more questions for macro? Awesome, great. So, they change our WPS qualification table in the clause for qualification. Here's a hint, everything underlined has changed. Before we didn't have a row for PJP groove welds. Generally, you always qualified PJP welds with a CJP qualification test. Now you can qualify it separate. Okay? Awesome. Does everybody know what a PJP is? Yes, I saw some other people shaking their head. So there's fillet welds, which is like the macro etch we were tossing around. CJPs, which is complete joint penetration, where you have prepped edges that go all the way through the thickness. And PJPs, which is partial joint penetration, which only goes part of the way through the thickness. Okay? Awesome. This is the fabrication section. This is the section we love. This is the one that tells me all the good nitty-gritty details that we like to talk about, right? The biggest thing are these two right here. My distances for my preheat and interpass has changed. It used to only be 3 inches or the thickness of my base metal. Now, if my material is 1.5 inches or less, then I need to preheat it at least twice the base metal thickness. And up to 3 inches. Or, no, it's just twice the base metal thickness. They took the 3 inches out of there. Goes to show that I do not memorize this. I reference it. Yeah, bless you. So for 1.5 inches and less, you only preheat to twice the base metal thickness. So you actually have to preheat less of an area because before the standard was it's always 3 inches or the base metal thickness. And that standard maintained for anything that's greater than 1.5 inches. I see that. And of course, if you're joining 2 pieces of metal, the thickest metal is the one that matters the most. You want to preheat that you want to use the preheat range that's composed of the thicker material, right? The last bullet point of there is probably the most important one, and this applies for all welding codes for everything you do, hammer it in your mind, right? Preheat and inner pass temperature shall be checked, which means it has to happen, just prior to initiating the arc for each pass. I cannot go under my preheat or inner pass temperatures, or over my inner pass temperature, my maximum inner pass temperature, before initiating each of those passes. I need to verify that, or have a way to verify that before I strike an arc each time. Generally done by temp gun, temp stick, or it's monitored by outside personnel, but there has to be some way to verify that our material is conforming to our specification, right? When I say specification, our WPS, our welding procedure specification. Okay? This is something new with fillet welds right here. It used to be defined to where we measure and inspect fillet welds across the face of the whole weld. Now, when I'm looking at fillet welds, I'm not just measuring my convexity and concavity across the whole face, but if I have if I'm doing a multi-pass fillet weld, I got 6 passes stacked up, and my middle pass is this big old mountain, but if I measure it across the whole face, then I could still be within tolerance. But when stress is applied across the joint and it's trying to go across that big mountain of a pass in the middle of my fillet weld, that's a huge stress riser. There's a huge change in the contour of the top of my material, right? So now something the code wants us to do, when we're fabricating, our weld profiles and my inspection doesn't just apply to the whole face, it also applies to the individual passes on the face. That way, I don't have one of my passes that are a lot higher or a lot lower than the adjacent welds next to it, right? Some of this stuff might sound like common sense, but you would be surprised. You'd be very surprised. Okay? Weld tabs. This is some new language. The important part is right here. For structural welding, weld tabs shall be used, that's that magic word again, shall be used at the ends of CJP groove joints to allow for weld started and termination outside the designated weld joint, except by these permissions right here. That means unless really any of these apply, you need to be using weld tabs for CJPs, right? To make sure that the majority of our indications that come, or defects that come at our starts and stops, right? How many is a welding student in Midlands Tech right now? Raise your hand. How many times have you stuck a rod? I guess you can't really raise your hand. You don't have 600 fingers. A lot, right? And it happens because people are humans. And that's why they want people to use weld tabs, because when they stick their rod and you mess up, you get that little bit of porosity and it makes you mad. It makes you a little less mad when you know it doesn't affect your weld inside of that joint designation, and you can remove your welding tabs and be happy at the end of the day, right? Yeah. It makes me a lot happier because now I don't have to reject welds, because they look good after your start and they look good before your stop. So it's good stuff, right? Weld tabs. Me and Nick were talking about this a little earlier today. This is a little get out of jail free card for fabricators. If they want to, they can get their engineers to look at it and get them out of using weld tabs based off of inspections and all that other good stuff. But yeah, those are exemptions for having to use weld tabs, but all other scenarios we should be using them. Okay? Inspection. We expanded a lot on the indications for MT and PT. I know it was one of the definitions we added. We talked about it a lot more. The big thing is how we're going to be interpreting them, what we're referencing back to. Kind of like Jim was talking about. He was talking about some crazy document, TC1A, which actually regulates and makes sure that we actually have written procedures for all these different inspections and make sure that we have a competent individual that's setting a criteria for us. But codes generally also have their own criteria, and they want to make sure that whenever you're doing this testing, you're not just referencing what someone's written procedure wants you to do, but they also want you to be in conformance of what D1.1 wants. And usually D1.1 requirements are defined for visual acceptance for surface discontinuities in table 8.1, which we're going to look at later, right? So they want to make sure you're doing what's specified by your level 3 for your NDT for the company, but they also want to make sure you're still meeting the minimum visual requirements for the code. Okay? Because generally PT and MT, they're just enhancing visual inspection. They're not actually looking inside of welds. Okay? Surface finishing, we need to be able to prep our welds to make it to where we can inspect easier, right? Depending on what we're doing, I can't perform PT or MT. Well, I can perform MT on most applications, but we need to have a certain surface cleanliness. I need to finish the surface that allows for non-destructive testing to occur, right? If I have spatter all over the place, or I have paint on a surface, if I have anything that's restricting me from doing my inspections, I need to make sure it's not there. I need to make sure that it's a surface that's available for inspections to occur, right? Awesome. Hey, personnel certification for inspectors. There's a lot of information right there. That's what we were kind of talking about before with TC1A and CP 189. If anybody wants to be a CWI one day or a non-destructive testing technician or operator, then I'd break this down. Talk to me later, right? We could talk about some of the different requirements. It's defined right here, what AWS recognizes as a NDT technician, right? What certifications are valid. A lot of information right there, okay? Let me know if you want to talk about it later. Visual acceptance criteria. This is a big, long, this is an excerpt from table 8.1. 8.1 goes over all the visual acceptance criteria. It'll take me a couple slides to paste it all right here. And I could talk for a few more hours about it, but I don't think y'all want me to. The biggest change is undercut. What is our allowable amount of undercut we can have on welds, right? One part specifically is for welds that are less than 12 inches. Before, we clearly defined for everything for greater than 12 inches, but not less than 12 inches. So for 12 inches and up, we were generally allowed for, well, it says it right there in A. Undercut shall not exceed 1/16 in depth for any accumulated 2 inches, right? For any 12 inches of weld. If you do less than 12 inches, then they want you to maintain the same 2:12 ratio, which is 0.16 for a length of undercut. You shouldn't have a continuous amount of undercut up to 1/16 of an inch. That is greater than that distance, right? Now there is something wrong with that right there, P and B, that they messed up when they wrote this. It says for welds less than 12 inches in length, the accumulated undercut length with undercut depth greater than 1/16 shall not exceed the weld length multiplied by 0.16 for each length of weld. That tells me what? What is my maximum amount of undercut I can have for something that's less than 0.16 long? What's my maximum amount of undercut? Maximum depth for undercut?
16.
Is that what it says? Is that what it says? For B here. It says it can be whatever depth I want. As long as it's greater than 1/16 of an inch, I'm good as long as it's not times 0.16 of the length of the weld. That is a typo. They typed that up wrong. I was actually in a meeting yesterday talking about this error and how it's going to be changed in the next errata we have. What all they're going to do in the new edition is put a no right there. That's all they're going to do. They're going to make it say no greater than 1/16 of an inch. All they did is miss the no. But now you'll know. Now you get to make fun of the code book, I guess. Yeah, sure. No. And then this has always been in here, but primary members, well, the weld is transverse to the computed tensile stress under any design load conditioning. Undercut shall not be more than 1/10,000th in depth. That's basically no undercut for welds that are transverse to computed tensile stress. That's always been there, but they just, I don't know what they changed as far as the wording. But it's something that's good to know, right? But yeah, that was a big error. That's been a lot of conversating in the code committees wanting to correct that, because generally inspection determines that, and when inspection changes something, they don't just change it in the D1.1 code, they try to change it in all the codes. So now we have multiple codes that have this error, and some codes called it and didn't make the error, but they didn't tell the other code committees, and now there's some inconsistency. But good stuff, good stuff. Stud welding. Man, we already talked about stud welding earlier. We are stud welding experts now, right? Because we know what flashing is. What's flashing? Yeah, the weld all the way around the base of the stud, right? We want 360 degrees around. So what they did change is they want type D studs. They added what type D studs. They're basically DBAs. They're basically not even studs. They're basically rebar that get shot onto structural components. And if you're hand welding them, you have to qualify to a different code that's not even D1.1. You have to qualify to D1.4. But it's basically DBAs and rebar, right? Unless you're super excited about studs, I'm gonna keep going.
How many of you ever shot?
Yeah. Awesome. Tubular structures. I have that underlined section there because out of all the changes to tubular structures, that's the underlined part is the only part I care about that's different, kind of weird. Something that's completely different than any of the other codes, right? Now, I can qualify procedures and qualify personnel to tubular structures in the 5G position and omit overhead welding. Someone could take a 5G test and do no overhead welding. Now in their qualification record, in the WPS, it will omit overhead as one of the positions, but apparently there's enough fabricators up there that lobbied for overhead welding to be able to be omitted from them taking tests. So there's a lot of the tubular qualifications for clause 10 actually require most welders to take a 6GR test in order to do the welds they want to do. So now there's a lot of welders out there in the Midwest that are welding up these wind turbines. Man, mine was blanking. And the test they're taking is a 6GR test, so it's a 6G pipe with a restriction ring, and they're not welding the bottom. But they also qualify the procedure like that. And it's allowed in the new edition of the code. Not necessarily something I agree with, but it's in the code. And that's what we go by, right? That is not a mistake. That is purposefully in there.
Is that just something because it's all down pressure, there is no chance of pressure coming up on it?
Yeah, why don't they do it?
Because too many people were failing. And they were losing money. That's what it is. They're failing their overhead section, so they're like, man, how do we get around this? And they changed the code.
So what, wind turbines falling apart in the Midwest?
No, they're just rolling them now. So, or they have people that qualify for all positions and they weld the overhead and then other people come and weld the other parts. It's kind of crazy. There's a lot of talks today about qualifying people for PJP well, this conversation happened 2 days ago, but qualifying people for PJP groove welds for tubular connections and qualifying other people to come in, do the root pass because so many people fail on the root pass for a 6GR test, and having people qualified just to where they can do the fill and cap.
How much paperwork do you want to do?
You're telling me. But it wouldn't surprise me if the 2030 code had that in there. It would not surprise me.
This says if it's not used in production welding.
Yeah. If it's not used in
They're
production
not
welding.
using it. They're not.
But yeah, people are trying to do some slick stuff. Now, this is the last real change, right? This is like the last slide. And I got a bonus question right here in case y'all want to hear me talk some more, right? When does clause 10 for tubular structures actually apply? What's defined as a tubular weld? Well, right now it's defined as any weld that's made on tube, right? So does that mean I need to do a 6GR test if I'm doing a fillet weld in the same axis on a tube?
It's on 2.
If it's on a tube, it's a tubular weld. By code, a lot of people think yes. That is not the intention of the code at all. If it's across a single axis, you don't have to. But if your axis of welding changes by more than 15 degrees while you're welding, then you need to take a tube test because you're having extra process variables thrown in there. But there's a lot of people that don't have the common sense. And there was actually a company out on the West Coast that had an outside inspector, and they said every single one of your welds you made for this whole project, even though it's all the same axis of welding, are rejected because you didn't qualify all your welders to a 6GR test. And it cost the company almost $2 million. And that company got very mad. Understandably so. Understandably so. And actually, because we don't have our next edition of the code coming out to 2030, AISC is coming out with their code. They're pushing out a standard, right? They release codes a little bit more frequently than AWS does, but they're actually giving us a chart to when the clause 10 applies and when it doesn't, because somebody got very mad. And in the 2030 edition, we're going to further define when clause 10 actually applies. It shouldn't apply unless you're changing your axis of welding by more than 15 degrees. If you're just doing straight welds, even if it's on tube, you should be able to take a regular plate test.
All that welding we didn't have to.
Correct. Because we're staying in the same axis of welding.
Yeah.
If you do a 1GR joint to where the joint's rotated, you don't have to test. You don't have to do extra tests. I'm saying that just for my Nucor people.
Yeah.
Over there in Hot Roll and Nucor, where they make everybody take that tube test, they do it for no reason.
Go back and tell Joe.
Tell Joe to call me.
I bet he will too.
He will, and yeah, he doesn't like change. It's okay.
No, he doesn't.
And that was the last slide. So overall, those are all the changes associated with the D1.1 code. I'm happy to provide this PowerPoint to anybody. I'm happy to talk about anything on this. Previously, I was talking about a hydrogen diffusion lab. We did a trial run with it yesterday, and the bubbles were really small, and then all of y'all would be bumping elbows and not being able to see it. But I'm still going to do a mock-up with it. So if we want to talk about hydrogen diffusion and actually see that, we could do it. It's just going to be a scaled-down demonstration. And then there was one more thing that I was potentially going to talk about after this.
I know you were talking about that micro edge, but you've already.
Yeah. I don't remember. Anything you want to talk about in relation to this? let me know. Hopefully y'all got enough pizza. I don't know how much is left.
I'm trying to get in a building where I can test and get a job, man. I don't complete this school.
Oh, that's the man you need to talk to right there.
I don't put an application in that orange field.
Yeah, talk his ear off. That'd be good. So, any questions for the group? It's okay. Good questions, bad questions, wild ones.
Your speaking skills are clear, Dave. Getting better.
Yes.
More hums.
I don't say quite as much.
Yeah, you're doing better.
I appreciate it, man. Anything else?